Okay, welcome to the MakeLine Blackbox tutorial. In this video we're going to look at how to take two position values and then create a series of particles drawing a line in between those two positions. This is going to be really useful anytime we need to visualize certain types of connections between particles, such as particle joints. And then what we're going to do is we're going to go ahead and build a different type of black box. We're going to build one called MakeLine Direction, which is very similar to MakeLine. And MakeLine Direction, though, it starts off with a starting position and then a direction vector and that world raster size, and it will kind of create a series of particles out in a specific direction starting from that position. Okay, so let's go ahead and get started. We know we're going to be creating a black box, so we're going to go ahead and start off with a nested dynamic set, and this is going to be our black box. Oops. Make line. And we're not going to worry too much about setting it up as a black box just yet. We just want to go ahead and build the thing and get the logic to work, and then we'll kind of set it up to be used as a black box. So the first thing we know we're going to need is 2 points in space. So we'll go ahead and duplicate a point 3 there. One of these positions is the origin, and the other one is right up in here, 100, 100. Okay, and so one of the things about this black box is we're going to need to know the distance between those 2 points. We're going to need to know the distance. We're going to need to define a kind of raster subdivision for them so we can know how many distinct points are defined along that length. So what we're going to do, of course, you might expect, is use the distance condition, since it automatically calculates distance for us. And just remember, the thing about distance condition is it's best to treat position 1 as your ending position and position 2 as your starting position. That way the direction output here is actually from the starting position toward the ending position. Okay, and then we're also going to need a user-defined value of world raster. And what we want to do then is we want to calculate, we've got that total length now coming out of the distance, and then we're going to go ahead and use our world raster value, whatever that is, to set up how many subdivisions we need. Let's go ahead and set our world raster value to 10, and obviously this is going to be some pretty simple math. We're just going to take the total distance between these two and divide it by the world raster. And make sure we've got our add multiply set up correctly. So this now is going to, and actually let's go ahead and create a memory node out here so that we can watch our progress. Let's get a scalar and go ahead and pull this scalar in. Actually, let's connect the scalar to the distance first. We'll turn on debug, and we'll see that the distance between this first point and the second point, right up in there, is about 141. So now, as of course, if we take that distance divided by 10, you would expect it's going to be about 14. Okay, so what do we do with this value? The value of 14, it's this total distance divided by our world raster. That's going to define how many steps occur. And those steps are going to be used by the iterator. And we use iterator, of course, because it can execute multiple commands per time sample. And we want to know that the distance divided by that world raster tells us how many times we want to execute this command. So we're going to take this result and put it into the count. I'm going to go ahead and move this down here to a little UI house cleaning. Okay, so now our iterator here is going to be outputting, and actually let's go ahead and check it just so we can see what happens. On one time sample, because we're currently set to per frame sampling, let's turn off edit on the fly. For every single time sample, iterator is going to output from 0 to our count minus 1. It outputs the total number of count values, that's 14 values, but starts at 0. Okay, so what do we do with this now? So we've got each of these numbers being sent out of the number output. We want to go ahead and use that number in conjunction with our world raster and the direction between those 2 points to kind of create a new vector per call. So what we'll do here is go ahead and we're going to need this number value, we're going to need our world raster value, and we're going to need our direction. And what this is really doing for us is when the iterator count, of course, is 0, the length, or the vector that we're going to be creating is actually 0, so that'll just be the starting position. But when we get to like 1, it's going to take 1 multiplied by the world raster to give us a value of 10, and then we need that direction to tell us, hey, I want you to move up this direction by 10 units, that multiplication that we made. But then when it comes to the next sample, say sample 2 is still going to use that same, we're always going to be using the same direction for each of these iterations, but it's basically going to be this new iterator number output multiplied by the world raster in that direction. So our number 2 vector is actually going to come out here like this, and it's going to create a particle here, whereas that first one was here, and even before that was at the origin. So here's what we're going to do. We're going to take an add multiply. We're going to take that number that's coming out of the iterator, remember our count value, we're going to multiply it by our world raster, and then we need to take this, and now this is kind of a length number, it's the length component of our vector, and then we need to multiply that by the direction that we want to create those particles. So we're going to go ahead and use an svec, which is just a vector, which is going to be this direction, multiplied by a scalar. And so what this will do is it will take the direction, which currently is a normalized vector, it's going to multiply it by a scalar value, which is going to give it a new length. And then what we'll do is, of course, we need to create some particles with that. So we'll use a position born. We'll start off, we want this to be a pistol shot per call, because we're going to be getting multiple calls from the iterator, since iterator outputs multiple times per sample. And then we also want to go ahead, we'll set the lifespan to be 0, speed 0, and alignment variation 0. And we'll go ahead and take that position value, and let's see what we get. Okay, so we've got a whole bunch of particles being created. We can take a look at the math if we like. Let's see. Let's clear our debug, write that value to debug, and take a look. Okay, so you can see 10, 20, 30, 40, and that's just a simple multiplication of our number with the world raster. Okay, so that's all fine and dandy. The only problem really is that we've got a starting position being defined, but you can see it never really reaches the ending position. So one of the things that we can do to cheat that really easily is simply increase that count by 1. So take an integer, we'll add 1 to it, and feed that there. Okay, so now we get that last point being created. And you can see, though, as we change our world raster, as we decrease that world raster, it's adding more sampling points in here. Let's go ahead and reveal our count and see what the count is doing. That count value comes from this integer. So right now it's creating 45 values, 45 samples in between there. And as we increase it, we can see that the number of count is going up. And of course that's all based on our world raster, our step size. Okay, so this has been pretty easy. Let's go ahead and clear our debug. Let's clean this up a little bit. Let's go ahead and prepare this to be used and saved as a black box. One thing we're going to do is create a new particle group. We're going to call it MakeLine, and MakeLine will assign it to a specific kind of color. It could be green, could be whatever. Usually try to choose something not too saturated, a little darker, just to indicate that it's not very important as a particle color. So let's see here. One of the things, let's change our MakeLine value there. Okay, so one of the things that we're going to want to do to treat this as a black box is we need to have these positions coming in be located not within this dynamic set, but actually outside the dynamic set. So it's going to be connected to the inputs of the dynamic set. So first, we're going to go ahead and take our starting position, position 2, and connect it up here. And we're going to go ahead and rename that to start posts so that people know when they use it, this is our starting position. And then position 1, of course, will end up being our ending post. Okay. And then one of the other things we want to do is we actually, it's a little hard to imagine sometimes, but we don't really want people to have to come into this dynamic set in order to start modifying values. We want them to be able to do it from the top level. So what we're going to do is we're going to take this world raster, take it out of here, and now of course we're up in this top dynamic set. I'm going to go ahead and paste that. And what we're going to do then is we're going to, these are the missing connections that world raster used to control. Go ahead and connect that there, rename it to world raster, and then we'll go ahead and whatever value we end up connecting there will also be fed to both of those. And so then we can take our world raster here, connect it as such, and now we'll go ahead and select all of this, right click, save. We're going to save this in the, if we can find it, our black boxes are all located under this particular directory. And we're going to save this in tutorials as MakeLine. Particle groups after loading. Of course, we're using a very specific particle group called MakeLine, so we either want to exist or create. If it already exists, go ahead and use it. Otherwise, create it. So exist or create. Okay, and so now what we'll do, and I should reorder that. That would be just good logic. Having the parameter which is being fed into something else should come before the black box itself, before it's being requested. So we'll go ahead and just resave that. MakeLine, replace, exist or create. Okay, so we've got that black box created. Let's go ahead and remove all that stuff and go ahead and test it. So now if we come down to tutorials, say MakeLine, we get our black box created, the data shows up in the right order, and now we can go ahead and create again just 2 simple position values. Our ending position, our starting position will be the origin, our ending position will come out, say way out X, and you can see that as we change this, it's automatically kind of calculating and drawing this line for us. And of course it will also do it in 3 dimensions. Oops, if we can keep it on screen. Okay, so this is pretty easily just the MakeLine black box, and this is very useful again whenever we deal with TP joints and we want to be able to draw lines between 2 particles to show that there's a connection between them. One of the things that might show up later is that the iterator on value might have to be specified. We'll kind of hold off on that right now, but that's something to be aware of. Sometimes if you have multiple particles calling this function, you will need this on value being added and specified, so that if we had a particle group, we would actually connect, say, that particle group to the on value, which would then tell the MakeLine run this iterator for every on connection that we have, basically for every particle that's calling it. We're going to hold off on that right now, and we're going to go ahead and get into the MakeLine direction.